Hi, today's notes will be about acids and bases. If you were here yesterday, we already wrote down acids and bases ECQs. Those are on page IP52. You should have a title and a page tab there. Write down the 3 ECQ questions before you start your notes on the next page. On page IP53, set up your page Cornell style. That includes a title for your notes, the essential question section, and a section for vocabulary and summary at the bottom. Here's your essential question. Describe the pH scale and the differences between acids and bases. An acid is a substance that can donate a hydrogen ion, which we sometimes write as H+. Please highlight this definition. It's very important. A chemical formula usually starts with capital H for hydrogen. An example, HCl usually represents a acid because it starts with a H in the front. HCl is hydrochloric acid. HCl is broken down into 2 parts, the hydrogen part, which makes it acidic, and the chlorine part, which is the other part of the formula. And letter B, characteristics of acids, they tend to taste sour. They produce a burning feeling on the skin, reacts with metals, we call that corroding the metal, or it corrodes metal, and it turns pH indicator paper, which we call litmus paper, red. We'll talk more about litmus paper later. A base, this is the second section of your notes, is a substance that can accept a hydrogen ion, or the H+, or a proton. Chemical formula usually end with OH, capital O for oxygen and capital O for hydrogen at the end. So for example, sodium hydroxide, or NaOH, represents a base because it has OH on the bottom, or at the end. Letter B, characteristics of bases are that they taste bitter, they feel soapy or slippery, they react with fatty acids, and they turn pH indicator paper, which we call litmus paper again, blue. It's the opposite of an acid. A neutralization reaction is the reaction between an acid and a base that produces water and a salt, which is, a salt again is a metal and a non-metal formed by an ionic bond. So for example, this is a neutralization reaction. HCl, the acid, plus NaOH, this is the base, remember acid here with a H, OH here to represent the base, yields H2O, water, and the salt, sodium chloride. Okay. As you see in the diagram below, that hydrogen here has become part of the water, and the oxygen here and the hydrogen at this last part has become part of the water too to make H2O. This is where you get the water from. Keep in mind that this is a chemical reaction because elements are all here following the law of conservation of mass, but they've all been mixed up and jumbled about in the final product. So it's a chemical reaction. It makes something different and new in the end. The pH scale indicates the acidity of a solution by measuring the concentration of hydrogen protons. The scale ranges from 0 to 14. Your acids are below 7, your neutral is straight at 7, and bases are above 7. And you would have drawn a picture of the pH scale in your notes already. The acid-base scale, you don't have to draw this, but here are some examples you can see and even add more to your picture that you already drew. As you see, everything at the bottom end at the scale of 0 to 1 area is more acidic. Everything at the 13, 14 area is more basic. So for example, very acidic things can be your stomach acid, which can range from 0 to 1 to 2. Lemons are around a pH of 2 or 2.3. Kimchi and oranges, citrus things, have a pH of around 2 to 3, depending on how acidic or sour they are. Your rainwater is about 6.2, slightly acidic. Not acid rain, which is a lot more acidic, but this is just a little bit slightly acidic. Your pure water is about 7, okay, very neutral. Blood is close to neutral, about 7.4, 7.5. Seawater starts getting a little basic. There's some salt in there. It's about 8.6 pH. Detergents that you use to wash your clothes are more basic, 10.5. Drano is very basic, 13.5, right, as on the pH scale. So you can add a few more to your picture. When you're done, continue on the video. A neutralization reaction, again, this is just a picture to show the example of when a acid and a base of two different pHs come together and you get something neutral. Yes, please draw this in your notes next to where you have neutralization reaction. Use the following question words. Remember, know what questions and do not repeat questions. Thank you. And your summary. Summarize your notes in 3 sentences by answering the essential question. Remember to number and highlight the periods. So what do you do in your summary? Answer the essential question. Don't forget the vocabulary on the bottom left. And you're done with the notes. Thank you very much.